Prove that sine A minus 2 sine cubed A over 2 cos cubed A minus cos A is equal to tan A. So in order to prove this, what we need to do is actually prove that our left-hand side is equal to our right-hand side. So on our left-hand side, like we said, we've got sine A minus 2 sine cubed A over 2 cos cubed A minus cos A. So the first thing we're going to do is we're actually going to factorise each of these, so factorise the numerator and factorise the denominator. So first of all, with the numerator, what we can do is take out a factor of sine A, because sine A is a factor of both sine A and 2 sine cubed A. And then inside the bracket, we're going to have 1 minus 2 sine squared A. And the reason we've got that is because actually sine A multiplied by 1 gives us sine A, and sine A multiplied by negative 2 sine squared A is going to give us negative 2 sine cubed A. Okay, great. So that's the numerator. Let's move on to the denominator. Well, on the denominator, what we can do is actually take out cos A as a factor. And then inside the bracket, we're going to have 2 cos squared A. And that's because cos A multiplied by 2 cos squared A will give us 2 cos cubed A. And then we've got minus 1, and that's because negative 1 multiplied by cos A gives us negative cos A. So now, to actually enable us to actually simplify this further, what we need to do is start to use some trigonometric identities, and we're actually going to use a couple to help us. The first one we're going to use is this one here. And this first identity is that sine squared A plus cos squared A is equal to 1. So what we say is sine squared of an angle plus the cosine squared of an angle is equal to 1. So how's this going to become useful in this question? Well, it becomes useful because on both the numerator and the denominator we have a 1. And therefore, actually using our relationship that we've got with our identity, we can see that these 1s are actually going to be equal to sine squared A plus cos squared A, which is going to be really useful because actually we're dealing with sine A's and sine squared A's and cos squared A's as actually part of our question. So now what we're going to do is actually use our identity, and when we actually substitute in our identity, we're going to get sine A over cos A multiplied by sine squared A plus cos squared A minus 2 sine squared A, and that's because we actually had a 1 there, which we'd already said is equal to sine squared A plus cos squared A, and then all over 2 cos squared A minus, and then again we've inserted using our trig identity, we've got sine squared A plus cos squared A. And as you've noticed, I've actually split the fraction into 2, so we've got the sine A over cos A separate, and that's because that will be useful in a minute using another trig identity. And now we're actually going to simplify, and when we do that, we're going to have sine A over cos A multiplied by cos squared A minus sine squared A on the numerator, and we got that because you had sine squared A, and then we've got minus 2 sine squared A, which gives us negative sine squared A, and then we've got our cos squared A, so that's cos squared A minus sine squared A. And then on the denominator we also have cos squared A minus sine squared A. And the reason we actually get this on the denominator is because we have 2 cos squared A, and then the reason I put in the brackets was obviously to avoid one of the common mistakes here, is we've now got minus cos squared A, and that's because we had the negative sign in front of the brackets, which means that the positive in front of the cos squared A becomes negative. So we've got 2 cos squared A minus cos squared A, which leaves us with cos squared A, and then we've just got minus sine squared A. Okay, great. So now we're actually going to simplify another step further, and we're going to do that using another one of our trigonometric identities, and this one is sine A over cos A is equal to tan A. So we can actually use that in the answer that we've got. So therefore what we're going to get is tan A and then just multiplied by 1. And the reason it's multiplied by 1 is because if you've got cos squared A minus sine squared A over cos squared A minus sine squared A, well, this is just equal to 1 because we can actually divide the top and bottom by the same thing. So we can divide the numerator and denominator by cos squared A minus sine squared A. So therefore we can say that the left hand side is equal to tan A, which is also equal to the right hand side because the right hand side was tan A. So therefore we can say that we've proved that sine A minus 2 sine cubed A over 2 cos cubed A minus cos A equals tan A, and we've shown all our working here.